Okay, good morning, folks. Sorry about that. A few technical issues. We're just getting sorted. My name's Fergus Sharkey. I'm the head of business supports and transport in SEAI, and I welcome you to the session this morning on the opportunities and challenges for commercial upgrades. So this is a really interesting space, and sometimes quite an ignored space when we're talking about the huge national retrofit challenge that we have ahead of us. A lot of people focus in on the domestic buildings, on the residential buildings, which in itself is a huge challenge and is about 7 million tonnes of emissions. But the commercial buildings, or the non-domestic buildings in the public sector and in the private sector, represent around 2.5–3 million tonnes of emissions as well. So it's a significant area. And there's big targets around this. There's a target for 2030 for 50,000 buildings to be retrofitted with a low emission heating system. So biomass boilers and heat pumps are going to be very popular. So it's an enormous challenge, but it's a challenge that we need to do a serious amount of work on versus where we are now. I'm very pleased that Eamon Shields joined us at the end of 2021, and we've started a commercial retrofit program within SEI for the first time. And we're starting to develop the solutions and support for this space. So you're very welcome this morning. I trust it'll be a very interesting discussion. Just want to thank all our speakers for giving up their time this morning and coming along. And I'll hand you over to Eamon for the rest of the day. So thank you, guys.
Hey, everyone. I'm really delighted that so many people were able to turn up. I know it's an extremely busy time in the industry, and especially Thursday morning at this time this is kind of, even with the best intentions, something's always going to land in. So I really appreciate everyone turning up. I suppose you'll have to bear with me. I'm a little bit less relaxed than usual. I'm used to having a forest or something behind me because we've been on WebEx for the past 2.5 years. So, but in terms of today, I think what I really wanted to achieve, I suppose, as part of the topic that we're covering today is, I suppose, is to help to bring together the goals of SEAI and then talk to the people out there who are actually carrying out these projects. Because it's really important. Obviously, we don't physically do projects. Our job is to assist the government in coming up with policy and then to implement that policy. But it's the people on the ground, the construction companies, the designers, the architects, and your clients in turn who own all these buildings that are the ones that physically make these changes. So without you on board, this isn't going to happen. Obviously, there are elements that we can do in terms of policy changes and regulations, and Part L is an example of that. But really, what we want to do is everyone in a positive manner to move ahead to what we're trying to achieve from 2030 and 2050. But again, the way we do that, we don't want it to be something that's a goal that we just hit and then we fall off a cliff at the end. We need to think about what we're doing to those buildings as we're retrofitting them, with a thought to after 2030 and 2050. What is the life cycle of those buildings in terms of embodied carbon? And also, like, how long will that building last because of the services or the systems or the facades that we're putting into it? So retrofit is the retrofitting of the buildings that are existing now, obviously, but those buildings that are being put up now are obviously going to be the retrofits of the future. And I know from my experience from commercial retrofit of offices, this is something that happens in a very cyclical manner. So today is really, I suppose, the start of increasing that communication between ourselves and the rest and the industry at large, so that you can inform what we are doing. Now, it's not a case that you can obviously drive it. Obviously, our goal is a pure goal of achieving sustainability. So your particular client's desires aren't something that we can necessarily directly take into account. But it's important to know what you're facing out there. So at the moment, there's a lot of talk about ESG, embodied carbon, LEED, BREEAM, and all these other elements that you're dealing with out there. So we want to have a collaboration, because obviously we're not a single entity on our own within the overall public sector. So we deal a huge amount with Enterprise Ireland, IDA. Obviously there's, the banking bodies and everything else. So we want to know what you need out there. It's not a case of, I suppose I was maybe guilty of it in the past when I was on the other side of the table, maybe not directly engaging in SEAI, and maybe there was a certain impression about how things operate in SEAI, But I can tell you, even from my first few months in there, that the level of positivity and genuine interest in helping and achieving to do things is real. So I suppose part of today, I suppose, is to help to increase that communication. So I think it's really important from your side as well, though, that you take part in that as well. So obviously we'll do things like this, but we want you to obviously contact us as well. Tell us about things that are happening out there. So for example, we had a big BIM seminar there early this morning from 8:30 to 10, and it was very good showing at that. And we want to know about those things, the technologies that you're dealing with out there. We want you to feel that we understand the language that you're speaking out there and the language that your clients are talking and asking to you about. And for the consultants and the project managers and those managing large sectors of corporate buildings for particular entities, we want you to be out there banging the drum as well, telling people, because obviously eventually regulations are going to come, but we don't want, that's not the tool that we want to use. We want people to start picking up the pace, so that when that train is coming, that you're up to pace and you can jump on it. And it might be a bit of a jump, but it's not a case that you're going from a standing start, because that's going to be a shock and it's not going to do anyone any favours. Okay, so again, as I say, we're not going to solve everything today. This is just a start of some discussions. So we've got some of the leaders in industry here from your side of the table to talk about a number of different subjects. And I will just hop along here. One thing to say is, this isn't a fact, or we're not going to ask you to do questions at the start of the presentation, although some presenters would probably prefer that. This is a very simple way of getting your questions to the people on the panel. So if you just go onto this website, Slido, www.sly.do, and enter in this code, you'll enter into this session, and all you simply have to do is just type in your question, and the question will come up. So maybe people don't want to stand up and ask a question, that's perfectly fine. We'll try to get as many as we can. Obviously, we have a number of speakers here, so it's important that we give them the time to speak, but we will take all the questions, and eventually they will all be answered by the prospective speakers. So without further ado, I'm sure you're sick of listening to me at this stage anyway. First two gentlemen up is Michael Curran. Michael is the Head of Building Services Energy in NUI Galway, and he's obviously the Chair of CIBSE Ireland also. And Tom Asco is the Managing Director of Symphony Energy. And they're going to talk about the sub-subject of challenges to commercial retrofit ventilation, energy efficiency and COVID. So, Michael, if you'd like to come up, and Tom, if you want to take your seat here. Where's left?
Morning, everyone. Thanks, Eamon. My name is Michael Curran. I'm Chair of CIBSE Ireland, which is a region of CIBSE worldwide, and we have about 850 members within Ireland at the minute. And we're always looking for new members if anybody's interested in joining CIBSE. But, excuse me, my day job is I'm Head of Energy and Utilities in NUI Galway. So, as Eamon was saying, we were presenting this morning. NUI Galway is a massive campus up along the River Corrib. We have 126 buildings, and from that we have 21,000 students and 3,000 staff. So it's quite a big campus we look after. And the topics I'm going to talk about today was COVID-19, CIBSE response, ventilation standards, CO2 levels, increase in energy in buildings, and then finally looking at options for the future. We all know what happened. 27th of March 2020, Taoiseach Leo Varadkar announces everybody must stay at home. So that began the journey of everyone working from home through Zoom and FaceTime and watching Netflix and watching programs and doing gardening and everything else. And we had the 2-meter distance. So this was a major shock to I suppose the whole Ireland, the way we do things. But interestingly enough, this was the 5 or 6 days beforehand on our BMS system. You can see the troughs. These were all our energy being used on that daily basis. Then Leo Varadkar made the announcement that everybody must stay home. And I got a text that night from our bursar, who's our finance officer, saying, make sure everything's off tomorrow. Make sure everything's off. We have to save. We have to save. But as you can see, it only dropped about 30%. We are research buildings. We have high-intensity buildings. You can't just switch off research. It's fine when you're in a teaching venue, you can turn off a light and do whatever. But we still have to maintain our buildings. And that was one thing that came out from us in COVID. While it did give us small savings and everything else. Like we were just got our figures there from the public sector, and our figure was it's 54.2% primary energy reduction. But we factored it's about 11% for COVID, but I think the results came out with 7%. So we're at 47.2% of what we actually use on a daily basis. We reduced, and that's through technologies like PV and fabric, heat pumps and wood pellet boilers, etc. So we've been targeting that for the last number of years through our ISO 50001 policy, plus research projects with SEI and HEA. But I just wanted to show that graph that it just wasn't for us. Everything was gone. That didn't happen, and that didn't happen throughout the whole of industry. Industry still had to work. So whilst we did make savings, they weren't massive. So going forward, at the time when COVID came out, a lot of the first year it was talking about droplets and surfaces, and then after a bit of research and more discussions throughout the year, it became that it wasn't airborne particles that was causing the issue. We had a lecture last night with Dr. Howell Davis, who's our technical director of CIBSE, and one of the items he explained was that I think it was the German government went to a village during COVID. They gave everyone a mask because they assumed it was airborne, and within basically a space of a week, they found that the whole COVID had reduced in numbers, and that's when more research began on that. And there's still research going. When I came in here this morning and I looked and I went, guys, I'm going to be talking about COVID. Can we open the windows? We need a bit more air circulation. So it is, and COVID numbers have gone up. So we have to be conscious of ventilation and air movement. So I'm not going to read through that because that was the statement coming through. CIBSE at the time got together, both throughout the UK and working with the WHO and REVA, and basically produced these documents and these are accessible documents. Anyone can download these documents, they're free. But it was given advice basically, emerging from lockdown. So this is back in probably the first documents were out in around November, and then there was other ones came out through the summer. So we produced documents on, returning back to your office, looking at COVID ventilation, looking at, lift use, etc. Like we always seen the signs, one person per lift. We've seen two people going up staircases back and forward and entering stuff like that. So these were just all the information they came up with. And then late July, they came up with the COVID air cleaning technologies. And that was through CIBSE, it was through the WHO, and it was through other bodies like ASHRAE, etc. So anyone that's, like, as Eamon was saying, I was 20 years a building service engineer, so CIBSE guides were my Bibles as such, talking about ventilation, heat loss, and strategies, etc. And REVA, again, and CIBSE and the WHO, all these documents were working together. So it wasn't just one, entity on its own. Everybody's working together. And again, all them documents are free to download. So more documents from ASHRAE, and then you can see the COVID-19 workplace protection. A lot of the stuff recommended there is the link to CIBSE again and what we were doing. So it's just to give you the strategies of moving forward. So as I say, under legal obligations this is where we're at the minute, you must provide sufficient air is provided in closed places of work, having regard to work and methods used and the physical demands placed on employers and employees. So that's what's guidance there, okay? There's not much more guidance than that, and it's the forced ventilation. We know a lot of buildings are naturally ventilated or mechanically. We'll go through that in a second. So again, industry guidance was in Ireland, there are no statutory requirements with regard to specific minimum ventilation rate to ensure a sufficiently well ventilated workplace where air is replaced at a reasonable rate. However, industry guidelines are summarised. So what we're saying here is, when COVID struck, there was a lot of different ideas of what it should be. There was different entities at different levels. So what we did is we picked out all these different regulations throughout, basically UK, Ireland, even America. But it was always, CIBSE and ASHRAE always had the figure of 10 litres per second. So if you see any documentation, it's all 10 litres per second. That's what the WHO came back on. Like there was different areas where, like years back, and I'll show you in a slide in a second, when all buildings were there was smoking and stuff like that, and then that's when people started changing back the levels of air volume, etc. So again, it started busy slide, but when the presentation is out, you can have a read through it. What did it mean? What did COVID actually mean when it happened in terms of ventilation? On the left-hand side, this was our lecture theatre in one of our buildings, capacity 200 people. But when the original stuff came out, we basically reduced it down to about 40%, with 2 metre spacings nose to nose. There was a lot of arguments. Is it nose to nose? Is it ear to ear? What is it, pencil? So Finally settled on nose to nose, set all that up again. That was fine through the first phase, then the second phase. Then what happened is then we worked more on our systems. It gave us time to work on our systems, and then it was basically we're down to 80% capacity over 100 spaces in it. So again, working on the 10 litres per second per person. So as you can see, there was a few people actually just jumped away from the chairs at the window. Natural ventilation is a standard that we use in terms of how we design our buildings, how we want to make them more energy efficient. We've been told, let's make our buildings energy efficient. We're looking at natural ventilation, how we do it in tours, okay? When it came out and you say, we want people to open the windows, it was like, you want us to open the windows? Like, and it's like not gone with the wind. We have to open the big window and the big blinds are flowing everywhere. Like, we're saying a small percentage is enough to create the airflow through it. We've done tests. Our colleagues in UCC, in the Buildings and Estates Department down there, actually went around and measured every window on the campus and the openings to make sure they had adequate ventilation. We did the same in a lot of our areas and looking at the way we did it. But natural ventilation still is a strategy, but it's, again, looking at thermal comfort. Again, looking at the natural ventilation, the openings. These are all standards within CIBSE, within the building regulations on single-sided or two-sided. So again, mechanical ventilation, which is a lot more we're familiar with, how we operate our systems, you know, how we design our systems. One of the key things that came out early on with the ventilation was, let's turn off our thermal wheels, we go 100% fresh air. That still stands. 100% fresh air still stands. It hasn't been changed. We're not recommending not to go away from that at the minute. I don't think we should be going away from it because the 100%, at least we're guaranteed. Okay, again, we're talking about we should be saving energy and we put in thermal wheels, we put in mixing boxes. Thermal wheels, yes, we're saying they can go back into operation once they're tested and stuff like that, but mixing boxes still not. Again, we're looking at it in terms of the way, you know, the word ventilation and air conditioning, oh, I have air conditioning, so I'm okay. No, air conditioning is within a space. It's not, unless it's ducted up the fresh air duct, it's not ventilation, it's cooling, it's comfort. It's the same with fan coil units. A lot of design over the years was basically, we bring a spigot to the back of it and we use the ceiling as a plenum. That's not typically 100% fresh air because you are mixing and come back through grills. So there's a bit of confusion. And I was going to put that slide up, but I said I'd just talk about it because they're actually doing some research in it in the UK, and I think it will provide some clear answers on it, but I still have a bit worried about that one. We all know design criteria. I'm not going to teach you how to redesign ventilation strategies and everything else, but it's very unclear there. But as you can see, very heavy smoking. We used to have 16 air changes in a space. So a lot of our old buildings used to be 16 air changes because they'd be at the lecture and they'd be smoking. Like, I've seen photographs of our campus where even the professor was standing having a cigar, you know, and all the plumes of smoke around him. So finally we got away from that. People went back down to about 8 litres per second, but we've always tried to maintain the 10 litres per second in terms of design. All these design criteria there, I know all the engineers are using them, so, but again, reference documents are there. So again, that's what we're talking about here, the 10 litres per second. As you can see, this has been in the CIBSE documents for quite a long time, and it basically tells you all the spaces. It's looking at the temperature, it's looking at, you know, the clothing factor, the temperature limits, the plus or minus 2, but the suggested air supply, it's always been there, 10 litres. When I was listening to the TV and the news, you know, people were talking about ventilation, this new thing called ventilation. Ventilation's been around a long time, you know, and someone's saying, yeah, but how do you explain it? The simple fact is, if you're driving along the car and it gets stuffy, you open the window. Put the window back up again when you're a thing. That's the same philosophy about working in an office. If it gets stuffy, open the door, open the window, get a bit of crossflow going on. But there was this new phrase, ventilation. It was hard to understand it, but anyway, look, it's been here for quite a long time. We did a lot of research about CO2 monitors, and we looked at different monitors, and we looked at different behaviors for our campus, and we tested them, and not that we don't trust people, but we put it through the rigors. We actually ended up using the RNet4 one. Sorry, I'll just go back. It's the one in the corner because it's digital. It gets through an app, okay? But we tested it. We did everything possible with that unit. We breathed on it. We banged it. We positioned it all over the room. And the reason we did that, because we know people were going to challenge us. And it's great when you have it on an app and someone goes, oh, my room is 4,000 ppm. And you're going, yeah, but you were breathing on it. No, it wasn't. Yeah, you were. Yeah. But if you look at this here, look, there it is. There. We can see when you touched it and you lifted it up and you were breathing on it. And they're like, no, we did. And it's like, there's the graph that we did to show what would happen, and you followed our graph perfectly. So again, you know, the CO2 was talked about quite a lot, used quite a lot. Department of Education have been putting in CO2 monitors within schools for years. It's in their guidance documents. They have the traffic light system, and they're used quite a lot. Again, it's about using an operation of these and setting the limits. These are the limits that basically we've been working on. These are the limits that are basically in other guides as well. So 800, well, outside is 400 parts per million, 800 to 1,000, keep all the windows, doors, 1,000 to 1,500, the windows and doors should be open at all times to ensure adequate ventilation, and then 15 to 2,000, open it up, go for a walk and come back. The sensors go up and down very quickly once there's a bit of fresh air movement. We recommended all these different recommendations, and these were all, I'm not read through all of them, but the big one was the 10 litres per second, and opening windows, etc. Design changes that need to, so this is sort of where we're looking at in terms of focus now. So the Climate Action Plan has set out these targets that we all have to achieve by 2030. We also, like in terms of, as Fergus was saying, the 50,000 buildings have to be retrofitted, and looking at it in terms of energy. What we've found is, and these are some of the things that we're looking at, is that there's an awful lot of nervousness about entering buildings. Delighted to see you all here today. It's great to be back, but a lot of people are still nervous. A lot of people are worried about what they're reading, what they're seeing. So it's up to the industry to make sure they go back safely. Working from home, do we need offices? People are happy working from home. Is it productive? Again, a lot of the industry are looking at hybrid options where you come into the office or you go bits and pieces. But new design standards are being developed. CIBSE and RIVA are looking at new design standards in terms of how we use our buildings, how we operate our buildings. Increased energy demands. As I said, our graph only dropped a small bit, but now that we're seeing the campus filling up again, and we're at 100% energy, and we're at 100% gas because we have to try and get that heat demand, our gas has gone up, but our electricity has gone up. We're in a lucky position where we can actually start offsetting those in other areas of the campus. But not everybody can do that, but you will see the spikes. There's been an amazing increased awareness of building services, of what's actually happening, how they operate, and that is the, we have everybody that's an immunologist now, they know everything about, everything, and now they're all becoming ventilation experts, and they start looking for more information, which is good, because people want to know how their buildings operate. They ask the question, well, how many parts per million you got there? How many air changes? What's a grill? What's a duct? So it's explaining that, making it simple for people. And the level of information post-COVID, we have a lot of information and data coming in ourselves in terms of CO2 levels, in terms of operation. So if you're a building operator or a client, get to know these stuff. And the increase the use of natural ventilation. Everybody, like for schools, for offices, whilst we're trying to keep buildings airtight, we still should be looking at that strategy. And then near zero energy in buildings, how we actually calculate all that. And again, the big one is that IAQ, at the indoor air quality, and I think Tom's going to talk a bit about that, so I'm not going to get too much into that. But we need to be looking at, design considerations going forward. Fergus was saying there about heat pumps. There's a lot of stuff needs to be thought about with heat pumps as a technology. Your ESB bill is going to go up. Is it reliable? It's a new technology. Thermal comfort, will I get what I need? And the other thing is, do we have the SB supply for it? Do we have the location for it? There's a lot of stuff that has to be considered. And whilst it's a new technology, we need to ask all these questions on running costs. If you're used to having a big gas boiler and you get your gas bill every month, it's a total different mindset, how we design, how we lay out everything. So there's a lot of design considerations that we're looking at from a point of view, both as clients as engineers. So there's a whole topic on that on its own. The things that we've learned from COVID, and I think even as an operator and a client, and even representing CIBSE, we need to go back to the basics. We need to look at thermal comfort. What is thermal comfort? We had a thing where in our library we weren't getting the temperature. But the simple thing, because there's so much air and we're 100% and the system's there, but a simple email went out to the students, please come dressed appropriately for the library. Wear a jumper, wear a coat. Don't want you to wear a hat, but wear a coat or a jumper. Dress appropriately. So thermal comfort has to be looked at. What do you expect when you go to work or at home? So that was actually quite good. Renewable energies. On our own campus, we have 400 kilowatts of PV installed. We need to be looking at that, see how that ties in. There is just our energy and our dependency. Obviously, the fuel price has gone up. I was sitting looking at my app beforehand, look at what's the solar. Go is actually lashing down today, so we're not getting very much today. But retrofit, I put this up. This is a tea cozy. And that's what we need to do. In our buildings, we need to basically put a T-cozy over them, retrofit them properly, look at fabric, look at the whole way we're doing these things. And again, there's strategies with ventilation and thermal and making sure the two thing. But then system design. System design is very important in terms of energy. What is the point in doing a complicated system of pipes that run all along there when I can just do a straight run of pipe, reduce the amount of demand energy within it? The big thing we're looking at as well is TM65, which is embodied energy and mechanical electrical services. The amount of carbon built in all your design of mechanical electrical services is huge. So you try and reduce that as much as possible. Keep it basic, keep it simple. So that's what I'm trying to get from this slide here. And again, challenges of ventilation. Do we need to put a big massive air handling unit up the roof that's going to take up load and everything else? Can we not look at localized systems? Can we not look at smaller systems? You know, so trying to minimize the amount of equipment. We had the opportunity. We've had a lot of learning for the last 2 years of how we operate. Really, we should be bringing them in. That's why I talk about new standards. Let's try and condense what we're doing, but still meet thermal and ventilation standards. And again, decarbonisation of buildings, you know, that's the big boiler here, but we want to put in this heat pump over here, 1 megawatt against 1 megawatt. Look at the footprint difference. But that's where we need to be. We need to get those learnings. So again, COVID gave us time to learn about these things and experiment. So again, information platforms, we were talking about this morning. BIM is not just about 3D models, it's about all the information. Get all the data, get as much data as possible. And again, looking at CO2 levels within offices, how does that operate? And again, Tom's going to talk a bit about that, so I'm not going to dwell on that bit. So again, lessons learned, that we've learned a lot of lessons for the last 2 years in terms of monitoring and how we do things. And again, look at energy efficiency and thermal modeling. Quite interesting side that we're looking at from that side. And my last slide is basically talking about indoor air quality. And again, we always have to remember and go back to basic. It's the person in the room that we are providing the space for. Are they are they comfortable in the space that they can work and produce what we need them to produce? And again, I think Tom is a great example of that coming up. So like, we need to just look at all these different things. Are they warm enough? Is it fresh enough? Containment free? You know, is it not too dry, ventilated, humid? All those things have to be considered. And I think COVID actually brought all that to the fore. A bit selfishly, as a building service engineer, I think it's actually moved us forward, because we have to basically say, you know, take the leadership in it. So on that note, I'm going to pass over to Tom. So Tom, I pass to you.
So, Michael, thank you very much for setting the scene in relation to ventilation and the challenges ahead. I'm just going to take a little pause in this at the moment and just break what I was going to say. My clients would kill me if I was to say that they have to put on coats. I have to actually deliver brilliant comfort and brilliant energy at the same time. So a little lesson in ventilation here. We've opened the windows top, middle, back. The gentlemen at the back, I think, have closed the window because it's just too cold. And the man in the middle has braved it. He's put a hat on his head and he has a fleece. And I am standing in a wind tunnel because the door is here and the window's there, and there's 8 degrees, 6 degree air flying through, and I know that I've been hiding behind Eamon Shields, who has kindly shielded me. So I'm just going to just tweak like they didn't go away, just reduce this a little bit so I don't freeze as well. We can open that up a little later if the sensor goes off. There are buildings, look, there's just too much to be done that you're not going to get the grade of performance and capability that you'll get from a building that's been built to grade A standards. But those grade A standards have been built and they want to get the performance out of the system, so they have to expect that. Now, pre-COVID, engineers, I would not exclude myself, were looking to respond to energy efficiency demands in the industry and the pressures there outside there. So we'd be looking to design to the lower bracket of the recommended ventilation air rates. Okay, so if it said, CIPSE said 8 to 10 litres per second, well, we go for 8. Well, because we have to be more energy conscious. And there was a general understanding that that was the responsible thing to do. COVID, however, turned that on its head. And now the world wants to have plenty of ventilation and lots of energy efficiency, and they are opposed. There's a working force. One, ventilation is more energy, and so on. So we really have a challenge ahead. But I want just to sort of preface this by saying that we have got some tremendous solutions that hit this absolutely top dead center. So if you listen on, you'll see some of them coming through. So what we effectively need is the most cost-efficient path to net zero. So there's a lot of companies saying we're going to be net zero by a certain time. Well, how much are they going to spend on that? And is it really just the Microsofts and the Intels and the big companies who've got tons of money to throw at these buildings and can do whatever they want? Or is it going to be ordinary businesses that have to really sort of work to tighter margins, and how are they going to tackle that? So we need the most cost-efficient path to net zero, and we need measurable ESG. That means we need to be able to measure and report upon the actual energy performance. It's not good enough to greenwash anymore. So how are we going to tackle this? So we need to look at our return on investment. We need to be mindful of design limitations. I say office there, but actually any building. We need to work out this tension between indoor air quality and energy. We need to be smart. Now, smart tech, yes, important, but smart in how we deal with the technology and the systems we have. And then we need to look at getting the microclimate to work most ideally, and from that, the microclimate changes around a building at any time. You need to follow if you do the microclimate well, you can bring diversity into the macro systems, your central HVAC plant. So if you get both of those working together, you can get incredible outcome. And then finally, just to put into absolute proof what I'm going to say in this presentation, that this really, really does work, we're going to use as a case study one of the most efficient buildings in this country. So any building got platinum, LEED Platinum in the last few years is in the top tier of energy efficient buildings in this country. I believe there's only a handful of LEED Platinum buildings in 2018, and that's pretty much as new as they come. So ESG, I want to show of hands in here. Who heard of ESG 2 years ago, or even just before 2021? Before? Okay, that's not bad. So that's maybe 10%. Well, you're more than I had. I hadn't really heard about it, but it was out there. It's been out there since 2005, but it's come like a tank in the last 6 to 9 months. And it's not coming at a regulatory level. It's coming at a global financial level. So companies are being forced through their finances to actually do this at a very, very top level throughout the industry. ESG does not allow any more greenwashing. You know, this sort of somewhat pretense of being energy efficient and whatnot. It looks for real measurable performance. You've got CEOs and CFOs, top management in companies, who are scrambling to be energy compliant because either their positions are now starting to hang on this, or their bonuses. I've seen this firsthand. And then you've got fund managers who are concerned about buildings becoming stranded assets. So if your building is not performing to the energy level that it's supposed to, then it'll be like a pariah. Nobody will be rented. It'll just stand there and it's a useless asset, so a stranded asset. So these are major concerns, massive stakes are out there. But then the question at the end of it is, can it be afforded? We've had some changing goalposts in relation to net zero. I'd say in the last 12 months, a lot of companies said we'll be net zero by 2030 or whatever, and that's very, very progressive, you'd say. But how much of that is 2030 on account of buying green energy credits for somebody else to fix the energy somewhere else in the world while their building pretty much stays the same? Well, again, with this ESG, that's not going to work or fly anymore. And then, of course, if you're going to meet ESG, you're going to be faced with the practicalities of retrofitting renewable energy technologies on your site. And if you're a building in the city centre or in a city, where are you going to have the space for that? So if your energy is up here and you need to get renewable energy matching that, I don't know how you're going to do it, quite frankly, without doing something else as well. So the first step must be to minimize your energy consumption. Now, invariably, our clients that we go to are doing a fantastic job already. And quite frankly, they have every reason to believe that they have got their energy minimized, or they might say, well, we've got a few things we're still doing and we'll get there. But I can assure you, based on our experience, they're about 50% off. there's still about 50% in general to be whipped out of any building across the city. And I dare say up to 80%, regularly up to 80%. And if you do that, then think about the implications for going to renewable after you've brought your energy consumption down by that amount. I mentioned design limitations, again, not just office, but any building in particular. And this dash to minimum fresh air, so we do have a little bit of a challenge out there. A lot of more modern buildings in the last 2 years have been built with smaller air handling units than ideal, which means that they can't really cope with the increased ventilation you want for COVID. On the one hand, they also can't increase to give free cooling when the outside temperature is suitable. Whereas if you had a larger AHU, you could always scale it down, make it run slower. Actually, a big fan working at a lower speed actually uses very little energy. So you can take a bigger unit, run it slower, and then if you have a situation where higher ventilation rates are required, you can ramp that up. So you got tremendous flexibility and tremendous possibilities for energy efficiency. Another one is chilled water. Chilled water can be exceptionally efficient if it's managed well, and I'll come into that in more detail later. And then with heating systems, a lot of heating systems are designed for high temperature, which means that how can you improve on that when you're in a retrofit situation? Well, actually there's a lot we can do. Obviously it's better to have designed for low temperature from the outset, but that does not mean that we're stuck and we have to go to the lower temperature systems. Okay. And here's the big question, the tension between indoor air quality and energy. They fight against each other. So more ventilation, wonderful, great, higher IAQ, better indoor air quality. But then you have got higher energy costs and by extrapolation, higher CO2 emissions. So that's the tension we need to work against. Now, the rates that were recommended, and Michael went into this in great detail, flipped around during the middle of COVID, but it's more pragmatically come back towards, I would say 800 ppm is a very healthy design target. I'm quoting here Professor Noakes, who was in the SIBSI Journal, published in the SIBSI Journal in November 2020. So she said, as a airborne infection expert, she said that 800 is fine, is good for airborne aerosols. And that you can kind of range it up a bit, but once you go over 1500, you need to be doing something about it. So if we target 800, we're really, really in good shape. And that would tie in with Michael's 10 litres per second. However, you have to be careful, because if you want to say, well, we're going to be super good on ppm CO2, you're into a situation of the rule of diminishing returns. So once you actually go below, I'd say, looking at that chart there, 4 or 5 litres per second, all of a sudden you're pushing tons more air and just marginally bringing down the CO2 ppm. So prior to COVID, you're more, the recommendations were more towards the 8 litres per second and the 1000 ppm. We're now pushing that down to the 12 litres, 10, 12 litres per second, which is the 8 to 900 ppm. So, and then if you want to go lower than that again, it's really futile, particularly from an energy perspective. The smart way, okay, not just smart tech. Smart tech, there's a lot of buildings out there, a lot of investment put in, a lot of smart technology in them. It becomes a train crash if it's not done right. And there's also, I'd say, a tipping point between how much you put into smart versus the actual return you'll get on it. But smart tech is really, really important. But I'd say equally or more important is just being smart in what you do with what you have. You need to sweat the assets you have. We can't just go into a building and say, yeah, we'll give you energy efficiency. We're just going to rip out all your central plant and put in modern plant, and there we go. So we need a big fat check to do that. No, that's not practical. It's not reasonable. And there's a tremendous opportunity, most likely in nearly every HVAC system that's reasonably well designed in every building across this country. So you need to sweat your assets. You need to get the most out of what you have. And I would particularly draw attention to the chilled water. If you've got chilled water in a building, so most medium to large buildings in the country are probably operating on chilled water for cooling. So chilled water, ventilation and heating. If you have chilled water in your building, as in from, announced this Energy Show 2022, there is a unique opportunity to be super energy efficient compared to any other means of cooling. There is now a patented heat recycling process that can be implemented onto any HVAC system with chilled water. It's done simply through programming your BMS. You don't have to bring a spanner into the workshop at all. You just get your local controls contractor to program this in. So how does it work? It's if you take an office environment, for example, it's winter, it's spring, it's autumn, you're still going to have, particularly if you have a well-insulated building and it's airtight, you're still going to have the hot spot in the meeting room. You're going to have the hot spot in the corner where the guys are gathering in the office. They need cooling, or they're going to be uncomfortable. So you need to have your cooling system running, albeit at a lower output than summertime, but you need to have year-round comfort cooling. So your chiller is on, and then you've got 8-degree air outside, or 6 degrees. You may get some of that up to maybe 10 or 12, whatever, with heat recovery, but you still need to bring it up to 16, 17, 18, 19, whatever is the sweet point for bringing that into your space to actually bring it in warm enough so you're not freezing people out of it. So you still have this heat demand and you've got this cooling demand in a building when it's all the year round. So what this patent process does is that normally your cooling coils in your air handling units are off because it's not summertime. You're not cooling the air, it's cold outside. But actually you turn them on and you run the cooling water through it because your cooling water outside of summer can be at a slightly higher temperature and can carry heat that can be dumped into the fresh air where it's needed. So you take the meeting room, you take the hotspot, the cooling water comes into those rooms, the fan coil runs the fan and the air through those cooling coils. That cooling water cools those spaces, and consequently the cooling water temperature goes up. Okay? That warm cooling water then goes back to the air handling unit and goes through the cooling coil, hits that 8-degree air or 12, whatever it is, and offloads that waste heat into the airstream where you need it. And that heating valve that's topping up the heat in the HU is either backing off entirely or at least it's substantially backing off. So your heating system can either switch off entirely or at least scale back. And on the other hand, your chiller, which was connected and in operation, and its primary pump can be off entirely. Okay? So you're getting this incredible free heating, free cooling. You're running your secondary chilled water pumps that you were going to run anyway, so you're getting 100% efficiency. You cannot beat 100% efficiency. Now, people always kind of quirk when I say, perpetual motion. Well, of course, that's not possible, all right? But you're having the same effect. You're getting free energy, and the input energy is already accounted for because there's a process already happening. So, in effect, it is perpetual motion in terms of the outcome. So that is a unique opportunity. It applies to every building across this country with chilled water cooling. It works between north and south 30 degrees of the equator around the world. It's patented across Europe, the USA, Canada, and so on. So it's in all the major developed countries of the world. And it's called Symphony Cycle. So that's the catch on it. So to implement it, you get a license and you get your controls contractor to put it in, and that's it. Second thing is you want to automate efficiency. So having your facilities manager having to sit by the BMS, trying to save energy and keep comfort at the same time, that's not practical for two reasons. The facilities manager is too busy to be doing that. It's a very, very inefficient use of human resources. And then he's always reacting, or most always reacting. So it's not as energy efficient as it could be if it was automated. So you really want to automate the efficiency. You may want to do some strategic upgrades to your HVAC plant. So now we're not talking about big changes, just clever changes, extra smart technology, maybe improve it, add a damper or an actuator of some form. And then you want to apply these high performance algorithms across your BMS. I'd suggest you put a device on top of your BMS so you're not messing with your incumbent BMS, but you put an automation server beside it, put your high performance algorithms in that, and then really automate your energy efficiency. And then ideally, and these kind of all go together, you want to bring it up in the cloud. We've heard of IoT, okay? There's companies not in our field who are doing tremendous things with IoT, but there's what I call HVAC IoT, heating, ventilation, air conditioning IoT, or even M&E IoT. And that's where you bring in the data from diverse systems in your building, and they create a picture, they create a signature for your building that can guide the best operation of your plant. So if you bring your BMS data up, your metering data, your data from your IAQ sensors, and you bring them into a common pool, and you allow the algorithms to work between all of that, you can all of a sudden get tremendous automated insights to drive your energy down and your efficiency up. Now, this here is one of the kind of the clever approaches. I mentioned earlier on the microclimate. This is really this is the answer to the tug of war between COVID and energy efficiency, as I've seen it in practice. This is where you want to get your microclimate right. So if you think of a building that's designed and commissioned, so every meeting room, every office space has got a variable control damper commissioned to give the right amount of air, design quantity of air into that space. So if it's a 10-person meeting room, you've got 10 times 10, 100 litres per second designed to go into that space. That's there all the time. Likewise for the office space, 1 person per 10 square meters or 8 square meters, the ventilation is based on that. So that air is pushing through all the time. But the meeting rooms are occupied by people who have come from the office space into the meeting room. So they've left a space where they no longer need the same amount of ventilation, and they've gone to a space where they do need the full amount of ventilation. So the micro solution is to have an indoor air quality sensor, a multi-sensor, that is tracking that CO2 in particular, but other factors as well, to know where the air demand is. And it's one thing to have the sensor telling you, yeah, you're okay or you're not okay. Then what you do when it's not okay? Well, do you have to go and open a window or leave the room? No, you want your multi-sensor, your intelligent sensor, to measure, of course, but also to control the local device that's responsible for delivering the air that you need automatically, okay? So the WellTech, we use a Symphony WellTech, a homegrown product, to do that precisely. It measures, it pushes it to the cloud, and then we have the device actually control a local motorized VCD. So we retrofit actuators onto VCDs and then have the device take care of the microclimate. And what you then have happen is that you'll have the office then can go down, the air supply can be turned down automatically, and then the meeting room office supply can open up. We can actually even push in more than the design quantity of air into an office space, because you can pull from one and push to the other. And even while you're doing that, in any building, there's going to be diversity between the spaces where people are. You just got to track the air, follow the people, follow the air. And when you have that microclimate working, that then brings back the macro savings from the central plant. The central plant can back off. And it can obviously come up and down to meet particular requirements, but by and large, it's backed off significantly while dealing and giving better than design IAQ. So what you get less air to heat and push, less air to heat and cool, less air to push, and then better than design IAQ. And here's natural ventilation working. Very good. yeah. Very. I think it needs to be open down there. It's down there. We're doing grand here, but anyway, yeah. So smash that thing. No. So the outcome is that we've basically nailed the problem of COVID ventilation and energy efficiency at the same time. So here we go. So, all right, that's it in theory, QED, let's say, but it's only in theory. So let's again look at a case study to see, in practice, did it work? And the case study I'm giving you is the LEED Platinum building, tip-top. If you can beat it there, if you make it work there, then you can make it work pretty much anywhere. So we've taken Hibernia REIT, recently been bought out, fantastic company, very on top of their game, LEED Platinum building, One Cumberland Place, very proud of their building, well designed, tightly operated. Good luck, see what you can do in that building for us. And so, okay, we said, yeah, we'll step up to that challenge. We implemented the patented Symphony cycle process. So we put that, they had chilled water, ventilation and heating, and we basically programmed their BMS to work that cycle. We've now had, this is fresh, so we only have a month's data. It went in at the end of February, so we've got March to look at it, and we're still fine-tuning it. However, in the whole month of March, we've got days like today, we had last week when it got quite sunny and quite pleasant. In that whole month, the chiller and the primary pump have been entirely off. This is a grade A building with a blue chip incumbent tenant, household name. They don't tolerate discomfort, yet their cooling chillers and primary pumps have been off entirely so far. That's indicative that with Symphony Cycle, you can be getting cooling for probably 6 to 8 months of the year for free. You can't beat that. You cannot beat that. So that's when the tension, the fight between VRF and chilled water is going to change from this day forward. So we're getting free cooling. On the other hand, the heating system has been able to back off much earlier. I'm seeing the heating system knock off at 6 and 8 degrees outside because the remaining amount of heat that's needed in an efficient building is that top-up heat on the air supply. And we're offloading that as waste heat gathered from the hotspots in the building. So we're seeing this free heating and free cooling. It is absolutely phenomenal. The impact that this has now for climate objectives across the world is absolutely phenomenal, and it's a very, very straightforward process to implement. So we have that in place. We're getting this free chilled water and free heat. The second thing was we tackled the microclimate. We put in there's an image on the diagram on the slide there, but we put in this Welltec multi-sensor, and it's sorting out the microclimate. You can see the CO2 levels are very healthy around the building. You see people loading into a meeting room, and the CO2 is going up. The next thing, the CO2 starts scaling down again, and then the AHUs are starting to respond, in kind, but always. We're finding that they're always still well down on what their design rates were, yet we're getting this tremendous better than design IAQ conditions in the building. With that, we retrofitted the motorized damper. So what did that's it in physical terms. What did it deliver in energy? Well, as I said, first of all, we got better than design IAQ. We've already halved the building, the energy consumption in a LEED Platinum building, a new LEED Platinum building in Dublin. So if we can do that on LEED Platinum, and we're not finished there yet, I reckon we're going to be well north of 50% in terms of energy reduction in this building. If we can do it in this building, then think about what can be done on other buildings across the city. And think then also what that will mean for being net zero and the scale of plant that will be required from a renewable perspective to resolve the remaining amount of energy that's needed for the building. It's going to save on the footprint, the capital cost, and then the operation and maintenance costs of the renewable plant in due course. So it really is a matter of QED when it comes to getting that combo of ideal indoor conditions and energy right down to the floor. So that's it. Thank you.
Hello? Oh yeah, you're there. Okay, so there's just two questions came in there. So Michael, I don't know if you want to take this one. So if you assume 70 people in the room and 10 litres a second, you need 21.5 kilowatts of heating for ventilation. If you have a heat recovery of 90% efficiency, should the heat load reduce by that 90%? Have a look there. I think essentially,
I know, yeah, just working on it there, yeah.
I think essentially what they're saying is it's about, in reality, will that officially 90% heat recovery unit actually save you 90%?
Yeah, it's, I suppose, will it? I'm not sure. As they said, that'd been like a medical question. It's been, I suppose, really you're looking at the surrounding areas and you're looking at the space, but we've looked at it from a point of view of, how much energy can we save within our systems that we have in our own plant, and 90% isn't the figure that we were looking at. It'd be a lot less, so.
Yeah,
but again, if someone wants to send us an email, then we can look at it for them.
Yeah, I think you're right. I think there's standard tests that allow them to say that 90, but I think over the course of it, I don't know if Tom, if you agree with that.
There's also, even if it is 90% efficient, you're bringing, say, air back at 23 degrees and you got 0 degrees outside. It's not going to bring it to 21 degrees. It's going to be somewhere halfway in between there in that. So you still have to top up that heat no matter how efficient your heat recovery is.
Yeah. And just one question there. Doesn't Part F state 10 litres a second in commercial buildings? So wouldn't that be the legal requirement?
Yeah, that is the legal requirement, but a lot of designs previously were looking at 8.
Yeah.
So as Tom was saying, like it does 8 to 10. The document does say that, but we're trying to enforce it more now. There was a bit of laxation in terms of design and where it was going in terms of systems.
Yeah.
So what we're saying is that is the figure. That's the figure that has to be used.
Yeah.
And even looking at I suppose, the standards now from the UK and the way they're developing. There's a lot more regulation, a lot more sort of building control and get a lot more involved, where I think there needs to be more concentration of, are we meeting those 10 litres per second? How are we commissioning? And in fairness, now a lot of the commissioning engineers that we work with, they're, the 10 litres per second ideal is always forefront where they're going.
Okay, yeah, that's great. Thanks a lot. Okay, we'll do a bit of a Lanigan's ball here. I think Tom and Michael, if you want to sit down, and then Oliver, Niall and Rachel, I presume will be back shortly, if you want to come over. Yeah, if you want to sit over there. You're the first, yeah. John, if you want to, and then you're last, John. Okay, thanks a lot for that. Yeah, certainly.
Maybe as part of this presentation, somebody's speaking to air tightness.
Air tightness. I'm not sure if it's on that topic, but we can probably ask the guys a question at the end. Yeah. Sorry.
Maybe previous speakers as well.
Yeah. Yeah.
It all starts with air ventilation.
Certainly. Yeah. Yeah. The facade is obviously very important. Yeah. No, that's fair enough. We can ask that question. Okay. So the next topic, which is being presented by Oliver Held of JLL, Rachel McGinley of CBRE, and John Gleeson of BPC. Isn't it, John? Yeah, sorry. I had another company in my head. I had to force myself not to say it. So, Oliver, if you want to come up first. Thank you.
Hi there. It's very good to be here today. Great to see such a good turnout. Okay, so I'm going to pose a question there. Does deep retrofit have to include facade replacement? I'm going to give you that. I'm trying to give you that answer from a building surveyor's perspective, somewhat very different to what Michael and Tom, a different, I suppose, starting point from Michael and Tom. I'm not an M&E engineer or designer. Anyway, let's see how we go with this. And I also would like to just kind of touch on one of Tom's points there with a LEED platinum building. So, okay, so just to cover key factors affecting facade replacement. I'm going to go through some case studies. I'm going to give you some a little guessing game. I'm not going to name the buildings, largely because I don't have full client approval to do so, but you probably will know most of them. And then just run through some key factors against facade replacement, and then key factors for, and then kind of bring us to conclusion. So I suppose over the years of surveying buildings, and now with the kind of more focused approach now of having to inspect buildings and report on how buildings can be improved and give clients the advice around how they can prevent their building from becoming stranded. We're looking at the nature of the building fabric, how it's put together, how the building was designed initially. Some buildings are going to be, prime candidates for replacement of facade, and some just don't need that really. So, I suppose slab to slab heights is a major, and the flexibility of the floor plate is a major component that needs to be looked at when you're, assessing a building for deep retrofit. If we take our 1960s building stock, which is probably diminishing quite quickly, they often didn't have they just don't have the slab to slab height that you need now to give that feeling of space and ensure that we get the indoor air quality that we need. And then even then into our 70s buildings, some of them can actually be deep retrofitted. And then obviously the newer stock, some of my agency colleagues would be saying that anything pre-2000 pretty much needs to be demolished, and that it doesn't meet, because it doesn't meet the requirements of a modern office occupant. But I would challenge that to a point. So then, yeah, you have to look at the extent of the retrofit that's planned, and really then again to touch on a point that Tom made was about return on investment. Is the capital expenditure that the client is going to put into the building, is that actually going to provide a return on investment? Again, a hot topic here, with buildings becoming stranded in 10 years' time, and I suppose clients are very concerned. I know JLL, we're developing a tool to try and assist clients in that process of of mapping out the energy and the deep retrofit, the forms of deep retrofit that can actually prevent your building from becoming stranded. But really, do clients have that capex to hand, or actually, if they don't have it, how do they get it? Because if they don't retrofit their building, is it actually going to be saleable? And will anyone actually want to purchase it? So, okay, case study 1, and we'll start with the LEED Platinum. This building was we both monitored for a third party the construction, and we also then did the project management fit out for the tenant. So this building, while it's fully glazed to the north facade, it's heavily or greatly insulated to the south, east, and west facades, and that's probably what has enabled it to get its LEED Platinum. So I suppose that is a it's a very recently occupied building. Next one there again, I'm sure some of you can recognise this building. JLL was involved in the monitoring of and the technical sign-off of the tenant fit out. And again, this building, it's very different from the previous building. It doesn't have a fully glazed facade. It has glazing within a brickwork facade to the front, and then a precast framed facade to the courtyard. Again, we've got rather than a LEED, we have a BREEAM score of outstanding. There are several other very clever components to the building that I say I'm probably not qualified to discuss. The next building is the building that JLL actually occupy one floor of, and the current landlord is currently undertaking a facade replacement of that building, along with other deep retrofit measures to bring that building up to a higher standard. As you see there, unlike the previous two buildings, this has a BER of E1, which obviously isn't great. But the facade is being replaced. So on the left we have the facade as it is now in progress, and then on the right then we have the designer's image of the finished product. So I'm afraid I can't tell you exactly what the new BR will be, but it's certainly going to be improved. Okay, the next building, I suppose I've thrown up there. Again, it's a bit more hidden away, so you may not know where exactly that is, and I'm not going to tell you today. But again, BR of E1, and there's a bit of a pattern here. We've got a steel frame facade, which is, I suppose, quite different to what you might expect, where you'd normally have a thermally broken aluminium frame facade. The facade is currently in it's operational, but there's certainly some requirements to there's some ability to improve its performance, replacing gaskets and what have you. But really, as I would see it, this would be a prime candidate for potential facade replacement, along with other deep retrofit measures. Again, whether the client chooses to do this or not, whether they have the funds available, again, is all to be questioned. Okay, and then lastly, then again, it's probably a bit more of a giveaway, but again, we have a hotel. Again, JLL is working for the current owner in terms of a renovation and extension project. But again, brickwork facade, mainly single glazed windows, would you believe, original to the 1988 construction. And, no need to replace the facade there, but absolutely is prime for upgrade. So I suppose then just going through some key factors, I suppose against facade replacement. I suppose one of the first things really just to cover is, I suppose, this when an investment fund or a private equity firm might purchase a building, say dating back to the early 2000s, they really don't envisage having to replace a facade where the life expectancy of that facade could easily be 40, 50 years. And so I suppose the realization then that all of a sudden when they maybe bought it 3 or 4 years ago, and then now that everyone's ratcheting up the pressure on deep retrofit, it's like, well, hang on, do we really have to do this? We've also got to think about the disruption to existing tenants. I mean, generally buildings, wouldn't be vacant. So like with our own building, I suppose the level of disruption is quite major. We have to now, we have with the sections of the facade that are being replaced, they've had to install solid partitioning in front of the glazing, a metre in from the facade. So desks have to be moved. That means a reduction in occupancy numbers. Again, not too much of a problem now, given the ongoing COVID situation, but still, it's a major disruption to tenants, and that has to be factored in. And then, of course, if you get tenants that aren't happy, are you going to have to give them rent free? Are you going to have to give them some kind of a rental reduction? Or, you've got to think about all these things with a building that is fully occupied, and how do you actually affect that facade replacement? Is it practical? I suppose again the high capex cost. I mean, again, for our building, the facade is in around the 2 million mark to replace that facade. So it's not a task that you undertake lightly, but it absolutely is required in some instances. Again, to the gentleman's point there about air tightness, and really, you can only go so far with services, and if you don't have a facade that's going to equal the improvement in services, then you're really not hitting the mark. I suppose then you have to look at the availability for grants, and this is something that Eamon mentioned. That the SEI, obviously want to try and assist owners out there and landlords in working through this deep retrofit process that we're all tasked with completing over the next number of years. And I suppose then, going back to this point of return on investment, that needs to be factored in and calculated. And I suppose, is it quite as simple as, well, if you don't do this, your building is going to be left behind, and really, when you come to sell it, will or not actually want to buy it? And finally, then, the point that I mentioned earlier was the slab to slab heights. Is it practical to actually do this? Are you going to actually get the building that occupiers are going to want to occupy, and that all factors into the assessment process before you would undertake any kind of work on the facade. Okay, so factors 4. Obviously, it's much easier where the developer or the owner has vacant possession. for the counter reasons that I discussed earlier. Again, as part of the process, normally there's an IES model that's produced to show the improvements that are going to be achieved from the deep retrofit, including facade. Again, touching on a point that John is going to, I think, talk to us about later, is the embodied carbon, and does that analysis actually support the deep retrofit as opposed to demolition? I think we all believe that, everyone should be retrofitting as opposed to demolishing, but maybe that will be touched on. And again, then just the slab to slab heights and the flexibility of the floor plate. If that's there, then that's all a checkbox for proceeding to the next stage. So the conclusion then really is, what I'd say is yes, facade replacement, should be considered or should be part of deep retrofit, but there are certain criteria that I think need to be met before you would go ahead and do that. And again, I've covered off on most of those already. So that really brings the end to my talk. Thank you.
Thanks very much, Oliver. I'm going to actually probably touch on some of the points you raised. Go next. So I haven't put my name on it. My name's Rachel McGinley. I'm Head of Sustainability at CBRE Ireland, and I've been working in that role right now for about 18 months. And in that role, I get exposed to sort of design, construction of retrofits and new builds, but also get quite involved in the buying, selling, and leasing of buildings. And I think one of the really interesting things I've sort of picked up is we've got loads of great engineering and ideas and designs of how we can make buildings better, but someone's got to pay for it. One of the big things we need to figure out in terms of retrofitting and making buildings more efficient is what's the business case and what are the market drivers for doing better. So I think, I moved to Ireland 18 months ago, and it started off as a really slow start as we were in the middle of COVID. And I think while we were there, all of our investor clients were sort of doing their ESG homework while they weren't buying anything. So they came back to market at the end of last year, and they had lots and lots of questions for us in terms of the energy performance and sustainability credentials of buildings they were looking at. And we're seeing market drivers for sustainability across the sort of all the different interests in commercial property. Investor demands are definitely different in terms of sustainability. They're getting more involved in reporting, doing GRESB surveys, and setting their own ESG goals for sustainability. The tenants that we have in the Dublin market are quite unique. We've got loads of the tech multinationals and big corporations. They're definitely starting to set their own either carbon targets as an organisation or looking after the health and well-being of their staff to, in that war for talent we have in Dublin. And then regulations are changing as well. We've got our climate action plan and EU regulations for sustainable finance, and those are really driving the questions that we're seeing our clients look at as well. And yeah, the big challenge is, as we know, we're trying to get to be carbon neutral by 2050, and we've got a 51% reduction that we need to meet by 2030. And I suppose the challenge, and I think sometimes when we concentrate on new buildings and LEED Platinum, is that 2/3 of the building stock that needs to be carbon neutral in 2050, that's already been built, so we really do need to be focusing on retrofitting and building performance as well as thinking about brand new NZ buildings. And our clients, both investors, building owners and tenants, do look at the whole sort of ESG spectrum. They look at environment, social and governance, but the biggest and the most tricky questions we're being asked about is about carbon and energy. Some of our tenants are quite, as I mentioned, quite concerned with health and well-being and social performance and governance in terms of reporting, but the really big driver we're seeing, and the one that we've actually got metrics for and benchmarks, is energy and carbon. And so we do some sort of surveys of investors year on year, and our most recent European investor survey found that 70% of European investors have adopted ESG criteria already in their investment decisions. And it's quite interesting to see across this graph here is Why are they doing that? And I think the answer is they're not doing it to save the planet. The big driver for them in terms of adopting ESG criteria is they're looking to protect the future value of their real estate assets. It's not, altruistic. It's something they see as being really important to maintaining property value, and that's why they're investing in it. And there's also huge market demands from the tenants in the Dublin market for looking at, well, across Ireland as well, for decarbonising the buildings that they occupy. There's a huge increase in the growth of reporting that big multinationals are doing and setting their own targets to be net zero carbon. And then there's also that focus on health and well-being in the workplace when they're trying to attract talent. And probably this is a little bit small for you to read, but I think the other thing that's changed quite recently, 2050 does feel like quite a long way away, particularly if you're thinking in terms of investment cycles, 10-year leases, 7-year sort of returns on buildings. But the Fit for 55 legislation that just came out that sets some targets for us to meet by 2030, I think that's really sort of putting things into context a little bit more. That's things we need to be thinking about now. It can't be pushed off any longer. So that's really bringing about a change in what our clients are asking of us. And the other big thing that came out at the end of last year is the RICS Sustainability Valuation Guidance. So in some of your companies at JLL as well, our valuers have guidance that they need to meet in doing valuation reports. And RICS, which is a big governing body, brought out some guidance on sustainability at the end of last year, something they've been working on for a very long time, I think. They don't move very fast. But now as part of these standardized valuation reports, sustainability will have to be a part of that. And the more that valuers report on sustainability, the more that they can really put some numbers to the business case for doing better. So one of the challenges we have is, particularly with European investors, they come to us and ask, how is this building performing? We do have BER as a benchmark of energy performance in Ireland, but there's probably things that we can be doing better. The big questions we are being asked is not just about design performance, but what is the real performance of the asset? And in particular, looking at energy use intensity and carbon use intensity, probably something that we don't necessarily have good answers to yet. So yeah, when we get asked information about buildings, the place you start is the BER. Hopefully we have it on record. And sometimes investors kind of hear, oh, it's got a C2, maybe it's not that great. But in the scheme of things, if you look at how buildings are performing in Ireland, it's the A's, the B's, and the C's that are top performers. They probably need to be better if we're going to meet carbon neutral, but it is quite interesting to put where that letter rating is in context in terms of the other building stock. But I think the one thing that we could really do with is looking at benchmarking of operational performance. There's a scheme in the UK called the REEB, the Real Estate Environmental Benchmark, and year on year, the members of the Better Building Partnership just report on their energy use by asset type and by area. So that gives you a really handy sort of benchmark of what typical and good performance is in a particular market. So it's not sort of saying anything about net zero carbon, it's just this is what we've got in the market, and here are some benchmarks. And because we don't have those in the island, I've been using these benchmarks with some of our clients just as an idea of where a building should be sitting in terms of energy use intensity. The other sort of exciting thing that's been happening is, so Neighbours is a scheme that's been running in Australia for quite a long time. I can't remember the name of the acronym, but similar to what I just showed you, it's an annual operational rating that looks at energy performance of an asset and just benchmarks it compared to the sort of square meterage of the building. It started off as a mandatory reporting requirement for government buildings in Australia, but slowly that scheme's been expanding. And you can see from the graph on the bottom right that just in terms of just having to report year on year saying what your energy use is, that's really driven improvements. It started off with just government leasing, and you can see the sort of graph of average energy use decreasing over time because people are being made to report on it and then assessing their own performance and trying to do better. And then the blue is disclosure for commercial office buildings, and a similar thing happened just by having to report year on year, making that public. It sort of forced improvements in the industry. And the graph to the top is Australia Square. That's a sort of 1960s building in the centre of Sydney. And just, yeah, again, by having to report year on year, it brought about really good improvements in the building because there was a focus on energy performance. Just year on year, they looked to improve, and it really did have a sort of significant impact on the building. And this has just been brought into the UK. Again, I think BRE and the Better Buildings Partnership have partnered to bring that to the UK. It's being trialled there at the moment. There's been some initial talks about whether this would be, I know some of our clients would love to see this in Ireland as well, because, yeah, just, you can't beat sort of operational benchmarking in terms of really assessing the performance of a building. So yeah, all our speakers today have talked about lots of really great engineering ideas that we could do to improve the performance of the building, but quite often with clients, there's a capital expenditure involved. So some of them are up for a big spend, depending on the business case of where that asset is sitting, but sometimes it has to be done over time. So there's sort of a process that you would go through with a client. It's not doing everything all at once. It's starting from some easy wins and working through in terms of improving that asset's performance. So, oh, sorry, the colors aren't that great. But I think this echoes some of the stuff that Tom was talking about earlier. It's just, first of all, finding out the information that you've got about that building. Quite often with older assets, you really don't have good information just about even what energy is being used and used by the different tenants. So if you start with looking at your data coverage and setting a benchmark for the building, then looking to reduce energy demand just by building management and using some of the smart systems you can to just make sure things are operating as they should. Then you can start looking at improving energy efficiency, on-site renewables, off-site renewables and reporting. So it doesn't all have to be all at once. It doesn't have to be a deep retrofit necessarily all in one go. And as Oliver mentioned, sometimes that can be difficult for commercial assets anyway, because you might have tenants in place and you might have to do it as a staged process rather than one big spend. But one of the quite nice things you can do, and I think maybe this is what you were sort of talking about before, is the CREM curve, that you can show that how interventions over time can get you on a trajectory towards being net zero. And that's sometimes, you're talking about lots of numbers with clients, and sometimes it just takes a simple graph for them to sort of really get what you might be trying to get towards. So this graph here is sorry, it's probably a little bit, some of the writing's a bit small. But on the whole, it's showing a trajectory to how a building should be sort of traveling towards net zero carbon. And you can show that maybe by not doing all your interventions all at once, you can sort of start with building tuning, replacing some chillers, PV on the roof, that you can kind of, rather than having it as one big project, do it over time to still maintain a trajectory towards being net zero, which is quite often more sort of commercially attractive to a client than one big spend all at once. So yeah, that's it from me. Yeah, I definitely think some of the issues is the business case rather than the engineering that we know how to do.
Hi everyone, my name is John Gleeson and I'm one of the founding members of BPC Engineers. Today I'm going to just give you a bit of feedback on the projects that we're involved in both nationally and internationally, specifically focusing in terms of carbon, how to measure it, LCA and embodied carbon. We're going to touch on operational carbon. We're going to look at an example of a refurbished building versus a new building. And we're going to go through some of the certifications that are there and being utilized in the market at this moment in time. So I think it's every single presenter before me has mentioned the importance of measurement. And without measurement, you can't improve it. And I'm using this quote here from a Belfast man, Lord Kelvin, who came up with the temperature scale that is used in general science, but I think is very appropriate for what we're going through today. In terms of carbon and why does it matter? Well, currently embodied carbon accounts for 11% of global emissions. And that is carbon that is consumed up to the point of practical completion. And that process of a building life cycle is carbon intensive. And once that is used up in that process, it really can't be reduced, as opposed to the likes of the operational carbon, which was mentioned in terms of previous speakers, in terms of the potential of power purchase agreements, etc., which is whereby large organizations predominantly are going into maybe a 15-year lease on something like a wind farm to offset their carbon emissions. And it's one way that they're reducing those. And we see that in terms of the building operations at the moment is currently 28%. But it's anticipated, due to large organizations moving towards things like power purchase agreements, which is adding additional renewable technology onto the grid, that over time, that operational carbon and embodied carbon will approximately account for an even split of the associated carbon emissions from buildings by 2050. The likes of an embodied carbon, as you see, the various stages that are part of the process of when embodied carbon is consumed, it involves the manufacturing emissions. So this involves the extraction of material, the associated energy and equivalent carbon emissions as a result of that, the transportation emissions, the installation emissions, the operational use phase emissions, and the end-of-life emissions. I suppose before we get into how embodied carbon is calculated, it's important to understand the life cycle analysis of a product. And this slide really just demonstrates that in terms of identifying the carbon in terms of the material extraction, the process manufacturing associated with it, the distribution and transport, and then the associated carbon emissions in terms of the operation phase and the end of life. So what happens in terms of products at the moment is that products get what is called an EPD. So it's an environmental product declaration. And this allows products to be measured in terms of their carbon performance. So whether it's something like plasterboard, something like insulation, concrete, etc., steel, all of these items are moving towards EPDs and getting this product declaration. And what that means then as we move on in terms of design process and architects and designers are considering different products, they can compare and contrast what that means to the embodied carbon of a building. How carbon is quantified, it's quantified in units which is referred to as kilograms of CO2e. The E stands for equivalency, and typically in terms of buildings, it's kilograms of CO2e per meter squared is the way it's brought back to. So when we look through here, whether it's steel, glass, electricity, concrete, etc., they all have the equivalent amount of concrete or the equivalent associated carbon emissions with them. And what you're finding now is that process, through the introduction of EPDs and softwares such as the likes of OneClick, which manages that process of EPDs, you can compare and contrast the implementation of these products on a particular project, where you would basically develop the equivalent of a bill of quantities and apply these products and see what is the overall embodied carbon of your proposed building. In terms of the embodied carbon life cycle, you have the various stages here in terms of the product stage, the construction stage, the in-use, end of life, and beyond end of life. The terminology that is typically used is cradle to gate, which is the manufacturing of the product, the associated transportation with that, to the gate of the factory. So it's as it leaves the gate of the factory. You then have cradle to practical completion, which I think is self-explanatory. It's in terms of the construction of the building and the practical completion of that. And then you have the likes of cradle to grave, which includes the end of life stage, and cradle to cradle, which includes the circular economy side of things. So when we look at those carbon emissions, whether it's the producing of a product or the transportation of a product, obviously the energy that is consumed has an associated carbon emissions. And these are just figures from the likes of SEAI's website. And I think what's interesting is the last three figures of the associated carbon emissions with regards to the grid electricity and how that has reduced year on year with the increased amount of renewables in terms of the grid. And that is happening partly to do with these power purchase agreements from these larger organizations that are going into 15 years, but partly in terms of other measures that are driving force for that. In terms of when we start to look at an example now, and again, like what our previous speakers have alluded to in terms of the potential of retrofit, I think if we take the likes of a sample building, I've just taken a notional building here, kind of a 1960s or 1970s building, and you might be fortunate that the tenant has moved out and you're now deciding, well, what will we do with this building? Will we refurbish it? Will we demolish it and build a new building? And I think it goes back to my very first slide, is that you have to measure it to see what is the best solution for your individual case. And if we look here in terms of the typical strategies that are implemented in terms of a new build, what you see is that on a new build you will typically incorporate the likes of 40% GGBS, which is basically a slag that's added to concrete, which greatly reduces the associated embodied carbon in the likes of concrete on a building. And then you also have elements like recyclable content in rebar and recyclable content in steel elements. And these are typically implemented in terms of new builds when we're looking at calculating the embodied carbon. So when you go through that whole process for this, say, particular notional building, and you look at the new build option versus the retrofit option, and you bring back the kilograms of CO2 per metre squared, what we're seeing here is the new build option comes out at just over 500 kilograms of CO2 equivalency per metre squared, whereas the retrofit option is slightly under 200. So you'd initially be saying, well, look, the graph tells the story, it's been measured, there's a saving in terms of the retrofit option. Well, maybe we have to go a step further. But before we go that step further in terms of evaluating if the retrofit option is the best solution for this scenario, it's to understand why is the new build consuming more carbon over the retrofit option. And the reason is self-explanatory in many respects, insofar as the new build will require new foundations, new substructure, new horizontal structures in terms of beams, floors, roofs, etc. Whereas the likes of, if there was a facade upgrade done in terms of the new build or the retrofit, they would be similarly like for like. There might be some slight differences in terms of the actual area, but typically they're like for like. And what we see here over in terms of the pie chart is really the effect of concrete in terms of buildings. And if we look at the likes of the foundations, the likes of the floors, like you're up to probably 60% of the embodied carbon of a building is coming from concrete, whereas the likes of the facade is probably about 18%. But when we're trying to weigh up which is the best option, you really need to start getting into, well, what is the operational carbon as a result of this retrofit? Because as previous speakers has spoken about, there is some constraints in terms of existing buildings, maybe things like air permeability, maybe things like thermal bridging, service voids, maybe floor to ceiling heights. And that's why it's important to really take into account the operational carbon and to look at the building life cycle over a much longer period to work out what is the correct approach for a particular building. In this case here, when we took into account the operational carbon saving, we tend to move to a carbon positive scenario after 12 years. So in my mind, in this case, and for other reasons which we'll outline later on, that would be potentially the better approach for this building, is to demolish, rebuild. But in doing that, there is a number of key fundamental things that we need to achieve, which we'll touch on in a later slide. In terms of certification, and to put that 500, and it often gets put to us as a question, well, 500 kilograms of CO2 equivalency per metre squared, is that good or bad, or where are we on that? And there is a number of voluntary certification schemes that really quantify what is good or bad in that regard. And interestingly, they have some slightly different figures associated with them. So the likes of the REBA 2030 challenge, which has a figure for commercial offices of 750 kilograms of CO2 equivalency per metre squared, we see our 512 actually is quite favourable against that in terms of reducing the embodied carbon. Whereas the likes of the zero carbon certification, which is a certification with used on a growing number of buildings, is used by the ILFI, which is a Living Future Institute. That has a target figure of 500 kilograms. So we'd actually have to go further if we were looking to get certified under the likes of the ILFI. And that then also incorporates operational carbon and power purchase agreements as well. As previous speakers have mentioned, there's the likes of LEED, BREEAM, GRESB, and there is Carbon Heroes as well. Now, what's interesting with embodied carbon is these are all voluntary schemes. So you would say, well, why would a developer do any of these measures if they're voluntary and there isn't a regulation? Because if we go back probably to the 2008 regulations, it was probably those and the introduction of those regulations that led people to improve the efficiency of buildings and the systems within buildings. Whereas here, what we're seeing is it's actually developer-led. And why it is developer-led is probably from the financing of projects, is that if we go back to, say, the first LEED projects that we were involved in probably about 10 years ago in Ireland, that was done by a multinational who had an ESG that they were looking to achieve, and therefore they got their LEED project certified. Where now we look around even across the road, all of these projects will be LEED certified, and many achieved the very, very highest ratings. And I think the reason is that sustainability can be quantified in terms of a value. It can be quantified in terms of a value, in terms of your repayment, maybe on loans. And if you have 100 million of a loan in terms of a commercial office development, now you can quantify the cost of doing some of these voluntary certification versus the benefits maybe in terms of the financials. And I think that's a really positive step that's happened over the last number of years. When we look at the recommendations and findings of what we've come across, the first is really what I've outlined, is really when you're looking at building life cycle, you should be looking at longer term. So you should be looking at maybe 60 years. And within that, there is going to be a certain amount of replacement that takes place. I think the fundamentals of whether you deep retrofit or demolish and rebuild, the fundamental thing is the lettability of the building. And I would be in many meetings in terms of with planning authorities where they will say, look, we don't care about the lettability of the building. We're trying to reduce the carbon. But they have to care about the lettability of the building, because if they look at the measurement and the building life cycle of 60 years, in some cases they will see that the demolishment is the actual better option. And I think we have to utilise the likes of the BCO guides. And it's interesting to note there, in terms of the BCO guides and floor to ceilings, that it's not developers or engineers necessarily that are coming up with these recommended floor to ceiling heights. We can see, based on the historic evidence within the BCO guide, that back in 2014 that floor to ceiling height was 2.45, where currently it's somewhere between 2.45 and 2.8, and in some cases higher. And I think the higher that we make that, the longer the likes of the structure, the foundations, etc., will be there, and their embodied carbon will be spelled out over a longer period than 60 years. The other item that is often not taken into account in terms of embodied carbon or operational carbon when you're looking at a new build is what is the effect of increased density on site. So given the changes in terms of planning, there may be potential to get more density on site, maybe a taller building. And this has knock-on effects in terms of the use of public transport. So if you have a building in a city centre environment, it's inevitable with the way planning laws are and the greatly reduced car parking available, that you're going to have more people using public transport, cycling, walking. And that in itself has a lower environmental impact per person. And I think that is very important for planning authorities to understand as well, that there is other positives that are not necessarily captured by the likes of these voluntary certification schemes. I think when you do the new build option, as is outlined by previous speakers, it's very important that you have flexible floor plates and efficient floor plates, because when you do look at the retrofit option, in some cases, it does involve the addition of maybe stair cores. It might involve new cores for lifts, toilets, etc., to meet the current standards. So even when you do a deep retrofit option, it's inevitable that there is going to be concrete added. There is going to be changes to the structure. And as a result of those changes, you may end up with more columns on a floor plate, which again affects the efficiency in terms of the number of staff that you can fit on a particular floor. I think, as is outlined through numerous speakers before me, having generous floor-to-ceiling heights, in my mind, is critical on any new build, because that ensures that when we're looking at maybe another evolution of this life cycle of the building, whether it be in 40 or 60 years' time, that the floor-to-ceiling heights are generous enough to allow the structure and the foundations to remain, and that the recladding and the relaying out of the building can be done in a flexible manner. As mentioned again in numerous speeches, in terms of the ESG, there is higher standards than ever before, but what's interesting is that those higher standards are actually being driven by developers as opposed to by regulation. And I think, again, that goes back to being able to quantify the associated benefits of these voluntary certification schemes. And that just brings me to the end of my presentation. Hopefully there's some food for thought there and some different reference points that you can go to learn more. So thank you very much.
Thanks very much for that. As John was saying, there's a huge amount of information there from all three speakers, and I think it's of untold benefit to have people like yourselves, like Oliver, looking at facades, and Rachel and John, just the stuff that clients are actually seeing out in the ground and things that clients are asking for, and the practicalities of deciding to change a facade. And that's the stuff that we're very conscious of within SEAI, that we don't come up with a concept that, okay, everyone needs to change the fabric before you put in a heat pump. We need to see we want to understand what the practicalities are out there. So that was a very valuable presentation. So last but not least, and sorry, I know we're running a little bit late, so the lads have been sitting there for a while. Niall and Keith are going to do their presentation, and it is on the benefits of building digitalisation and optimisation. So Niall is an associate director with Axis Eng, M&E Consulting Engineers, and Keith works for Cirrus, who do a huge amount of control technology. He won't tell me what his official title is. He's like part of their SWAT team. Apparently, he just goes and sorts things out. So thanks very much, Niall, if you want to kick off.
Thanks very much, Eamon. Glad you remembered where I worked for a change anyway, unlike John. So I'm Niall Hurley. I work for Axis Engineering. I'm a building services engineer, and I suppose as the other speakers have kind of gone through facade upgrades, energy monitoring, I suppose what I'd like to go through today in terms of what we're doing with our clients at the minute and looking at how we can implement some digitization, and we do a good bit of stuff with Keith as well on some buildings maybe across the road from here, and what we've found and what we've changed, and I suppose the items we've implemented to make everything a bit more efficient. So I guess, firstly, I think we've gone through some of them previously, but I'd like to touch on some of the stuff that our clients are coming back to us in terms of what's driving them towards the energy initiatives, why are we, and how the digitization can help that. Kind of the process we work through with them to work out what we can do in their existing buildings, how we can reuse some of the stuff Michael and Tom touched on, how we can reuse what's already there, how we can make, I suppose, some of the systems work a bit better for them by putting in small changes in BMS or metering or energy management. A couple of project examples then on metering systems we've put in. And I think although we can record a lot of stuff, it's probably how we present it to the end user and how the end user sees it. Like, it's easy for us as engineers standing here
we're kind of trained to look at graphs, but how do we make that visually better for tenants, and how can we overlay it so that, I suppose, it's not just the end user looking at it, it's the tenant and the people occupying the building are I suppose, paying attention to the graphs. It's kind of right in their face. They know that they have an impact, and maybe we can change the staff behaviour as well as the developer behaviour. And then we'll touch a little bit on ventilation. I'll go quickly over that because the guys have done it. And then again, how we can implement heat maps, occupancy profiles, stuff we've done on that, using existing systems to make, I suppose, life a bit better for everybody. So then, I suppose, to touch on the kind of drivers that we're seeing from people, a lot of it's kind of gone through before, but there's all the I suppose the obvious ones that the guys touched on, like regulation, part L, what's it telling us, what are the EU directives telling us, and that's fine. Like, as an engineer, we're all used to looking at the codes. We have to do that. We have to implement those. But what we're having, I suppose, from some of our clients, where is the funding coming from? How can I report back? How can I guarantee that funding? Again, across the road, we've got end users. They can go into IKEA and buy a smart light switch that they can control on their phone. They can control the lights in their house from their phone. Why can't I do that here? Or can I make that a bit better? So I know Keith's going to look at a few bits like that. We're bringing stuff onto the cloud, how we do that kind of stuff, and how we can get that to work. Because if you can do it at home, that's the user experience people want. And when they're coming back to the office, that's what they're actually going to want to be able to do in their office. Again, we've got other users, I know guys touching it. They don't want to use fossil fuels anymore, so they're trying to use that. They're asking us, how can we monitor how much fossil fuels we're using? How can we change our energy profile, whether it's through improving our chilled water efficiency again in other buildings. For example, across here, they've got cooling towers. We're looking at how we can use them better to improve their free cooling cycle and how they can report back on that. So it's all from that level down, and then it's again from the organisation and their staff. How do they make it better for everybody within their staff to, I suppose, come into a building, know they're working in an energy efficient building, what improvements the company is doing and the organisational culture, whether it's the drivers to get to net zero, whether it's to create a better environment from an indoor air quality for their staff, or whether it's a bit of both and how their staff, I guess, are involved on that journey. So I suppose in terms of how we do it and where we get there with clients and how we implement the solutions and the technologies, I suppose our first step is to look at the building, sit down. What have you got? Have you got an existing system we can reuse? Is there like a smart DALI lighting system there? Is there some ventilation systems in there that we can reuse? So I'll work through the systems. How can we bring them all together onto a hub? Again, it's like, I think Rachel touched on earlier, it doesn't all have to be done at once. There's a BMS system there. We can implement some of the stuff now from this year's funding, maybe 2 years' time we can do a bit more. Again, I suppose one of the lessons learned that we've had from working through everything and I suppose in implementing stuff with clients is the kind of testing and the framework and the development. So I suppose if we're putting it onto a client system, don't do it straight away. Make sure we do two-stage commissioning. Make sure we get it all working up in front. Everyone's signed off on it before it's kind of rolled out up onto their server and they can do it all. So again, it's the final verification. It's not just we're finished, the door shut, there's PC, that project's finished. It's how we can continually improve using, I guess, the technologies that are out there, using the analytical data we can take from the BMS. So we might think day one we've set the building up correctly and it's grand, we've all walked around, we've met the temperatures, but the tenant moves in and they're not happy. Well, why are they not happy, or why is it not working for them? So I think it's doing the audits, coming back, gathering the information, and again we're using a lot of the metering data that we've got to be able to do that. So I suppose I just want to skip on to a project example that we've implemented recently, and I think it's to try and make, I suppose, the existing building had, I suppose, plenty of meters. There's a lot of buildings we've done out there. I know the guys touched on LEED Platinum, well buildings, we're doing all that, but a lot of the time the meters go in, but what do we really use them for? The meters are there because we have to manage tenant energy, we have to manage tenant lighting consumption, we have to meter this, but it can be a bit of a tick the box in terms of a LEED. We've met the criteria, all the meters are in there, they're all networked, they're all back to the BMS, but when we see a graph with lots of stuff overlaid on it, how does it really relate back to what the tenant needs, or to improve, I suppose, their energy consumption, or to drive the FM guys? So I suppose in this building we overlaid an energy manager system on top of it. So it gives us live data. It can compare period on period energy use. It can compare floor on floor energy use. So it can kind of, I suppose, influence behavior. So what it can be done is to do all the reporting, so we can automatically set up any reporting you need for your funders or anything like that to do that. But also it allows, I suppose, us to compare each floor, and it can be set up in a kiosk mode, so it can be displayed all around the office. So we can do things like, am I using more carbon today than yesterday? And we've done, like, I suppose, simple, silly things like thumbs up, thumbs down for staff going in, so they know if they're using more energy, if they're using more CO2, and they can probably impact their behaviour. So, right, you can use it to compare department against department or floor against floor, saying, right, well, our department used way more. And you can see here the orange one on the fifth floor. All the floor plates are similar size, and I suppose the orange one, why is that using way more energy? And it came back to, I suppose, a fault-finding exercise that some of the lighting controls weren't set up, so it wasn't daylight harvesting properly on that floor. But you can see it straight away here when you do it on a bar chart. Again, the end users are, I suppose, able to go in and compare on a day-by-day basis what they're doing, the energy you're utilising, and it's, I suppose, a very simple retrofit. It's an overlay on the majority of buildings that have in around town that have got lead or well in there. You can go in, collect all the data, collect all the meters, and again, I suppose what we're looking at on this client as well is that it gets rolled out across their portfolio of buildings, so they compare one building to the next. It influences the various kinds of work they're doing on each building, and they can compare FM uses, like the buildings. Why is one building performing better than the other, and can we implement some of the energy efficiency measures in terms of maybe temperature bands or control that we've got in those buildings to spread the efficiencies across the portfolio. And also they can use the energy to report against the whole project portfolio rather than one building at a time. So I think it's in terms of a retrofit solution, or there's a lot of learnings that clients can take from it, and it really doesn't take that long to implement. And I think I suppose from our point of view, it's the graphics for end users are easier if you can display it in a simple way that they understand, and it will change their behavior. Again, I suppose in terms of CO2 and ventilation efficiencies, I think it's again trying to use what we've got. So again, nearly every building we've done in the last few years has put in CO sensors in commonly occupied areas as part of a LEED program, as part of a well program. But again, a lot of them are just sitting there with an alarm on them for a high level alarm, but nothing really happens. And again, it was similar probably across there that we had a building that we completed, and Keith's been involved in it, putting in the CO2 sensors, using the ones that are already there with some additional dampers to actually manage the ventilation, spread the ventilation around, ramp the AHU fans. All our AHUs we specify and buy tend to come with inverters on them anyway, so it's just a case of managing that, and we can ramp it up and down. And as you know from earlier, the fan power makes a big, massive difference on our energy use, and we can drop the ventilation by a bit, we'll get good returns on our fan power. But again, it shouldn't take a lot of work. Yes, we have some dampers to put in, but majority of the cases we have the CO2 sensors in there in relatively new buildings. And again, there is always wireless solutions for the CO2 sensors that you can go back in. Again, it does assist obviously with our energy use and in productivity as well. And I suppose the last one that I wanted to touch on as a project example was the heat mapping and what we're doing. So again, we've got, I suppose, we would have traditionally had room booking systems that we've used for various clients, and they still use them for room booking, so we can take data from that. But the problem with the room booking systems, a lot of time, unless it's some of the really fancy ones, you don't know whether that's smart. You don't know how well the room's been used. You don't know if it's actually been occupied. You don't know if your ventilation system's working or not. So we can use DALI lighting systems to get some information back. So the room was booked. Is it actually used? is the room unoccupied, we can set back the temperature in that room. So we can pre-purge rooms for some of the larger meeting rooms and spaces before people come in, so they're ready for occupation. We can see if general areas of the office, are they actually used. Again, the FM teams are using some of this information from the room booking and from this to see if rooms are actually occupied. Do they need to clean the rooms? Do they actually need staff there? Do they need to bring 5 people from somewhere else in to work in the building? Maybe they don't, because the rooms they might be booked on the room booking system, but they're empty. So I think in terms of integration of it, it kind of monitors, you can monitor the room use. We can use it for our ventilation setback. We can use it to, I suppose, control our high level and low level alarms, our high level and low level temperatures and times of operation of the building. We might find that, again, with people coming back into the office or not so much coming back into the office, depending on your organisation, it allows you maybe just to not have every area in the building assumed to be fully occupied, because you know the times that people are coming in as well. So again, it helps with the FM teams. And again, I suppose what I'm trying to pick out is the bits that we've implemented previously or can implement, where we've got existing systems that are already in the building that we can reuse. So I suppose I'll try to go quick, because I know we're tight on time. Just, I suppose, in summary, Keith is going to show us how the technology works, but in summary, from our point of view, working with our clients, the technology, and particularly the metering stuff we've done, really allows us to see the energy savings across the portfolio. It will help then identify plant and kit that maybe we can change out through energy efficient initiatives with maybe SAI and promote, right, if we change out this plant, or we've got this plant in one project, this bit of equipment in another, this building's performing a lot better because of that. It kind of allows that to be identified. It can, depending on how we use our information, change some of the culture, the staff behaviour. So do I really need it set, my temperature set to 23 degrees in the office? Am I always really that cold? Or maybe I don't need to walk around in a t-shirt, or maybe I just need to close that window and wear a jumper rather than standing here in a shirt. But that's how we can impact behaviours. We can, again, assist with commissioning and fault finding as well. Through the more data we get back, the more efficiently we can operate our buildings. So again, a lot of the sensors we're using, they're all there. We're not just not taking the information back, or we're not presenting it in a way that's easy to understand for any layperson. We've got very complicated graphs. So I think it's trying to take all that information from the digital stuff we've already got. We don't need to overlay lots on it, because we've put a lot of technology into buildings, and then that can, I suppose, identify further opportunities for saving through plant and equipment and replacement strategies. So that's about it for me. I'm going to hand over to Keith, who's
How you doing? I'm Keith Fitzpatrick from SARS, heading towards 30 years in the controls industry. Started when I was 6. So I'm here to talk on something that we in SARS we're very passionate about. Obviously, it's digital buildings, we're IoT ready, bringing the health systems forward. So we'll start. I won't get Anaraki. I'll try and be less techy as possible. Just get through it. I do CPD accredited courses in this, where we do deep dives into different aspects. But for the time constraints we have, and everyone had eaten up the time, so we'll be as quick as we can. Yeah. And we will touch on security levels, because that's a topic that's very important to people as well. The digital building automation transformation has been happening for years, and it's been coming on. So we started off traditional buildings prior to 2010. We had a massive change then, where we started looking at different services. We started looking at preventative and picking out how can we make buildings more efficient. So it used to be based on calendars and malfunctions. Then we moved on. It was based on checklists and specifications, which was a big step forward. Then more in recent years, we're coming to this smart IoT sort of level. We're talking about now, we're actually predicting things. We're taking analytic data and being able to predict what's going to happen in the space, whether it be used by more people, or we're seeing trends, stuff's changing, so we predict outages and failures. So it's acquiring that data and how we use it. A lot of the talkers there have talked about that in this roundabout way. We're also going through how we actually make that happen. And we are going to a level now where the building has an inbuilt intelligence, where it's actually self-performing, it's making these changes without any human intervention. And this isn't concept, this is reality, we're doing it. This is real, with lots of large companies, but it shouldn't be held to the big blue chip high-tech companies. We think this is scalable down to the smaller users, or even down to your small office block or your school or wherever. And it doesn't always mean we need to rip everything out and start again, or buy all new equipment, which we'll touch on, show how we actually use and utilize as much as possible the infrastructure that's already in place. Back years prior to the 80s, it was all analog, and and we had pneumatic controls and stuff like that. But in 1980, we started got into the BMS, and things started to move, and it was really a turning point in the controls industry. The black art, as it was referred to back then, but we moved on. And then later on became the internet. The internet started to we be able to see the systems, connectivity, sharing information, so that started to build, and it was a massive turning point. Now, with the development of the products and the equipment that's available to us as controls companies and designers, we have intelligent sensors, multi-sensors, intelligent actuators, stuff like that. So that's made it so much easier, and the connectivity. And we're moving now, so we have this ambient intelligence, so we can take that information and this data analytics back and use that to drive the building forward and reduce the energy. And as we go on, we're combining these together with smart homes, all this stuff together into a proper building IoT solution, and that's the roadmap is very clearly there. Smart building, standardize. Standardize, monitor, accountability, rethink, and transformation. That's where we think. Standardize, getting all of the communication protocols in the building into some sort of recognized and good standard. Most buildings, most designers have gone well and truly down that road. There's a clear roadmap for that as well, and that's happening. Monitor and minimize consumption. Use the data, make the building more efficient. And accountability, like as designers and as suppliers, as installers, we have to take some responsibility for the customers and their needs, and to deliver the project as best we can, and through the lifetime of the building. Rethink, look outside, take the information that you have received. How can we use that information to improve the building and make them implemented changes and to be able to quantify them through metering and whatever. And then transformation, basically take the information division from the building automation system and use with cloud services. The cloud services, where this is the area we're going to now, and it's been fearful. A lot of people have fear of it, but we're trying to break that down. That there's no reason to have fear of this. This is a very secure, very safe way to take information. When we use the word cloud, it doesn't mean we have to go out into the internet, onto servers and data centers elsewhere. We use the cloud can be on premises. We can create this situation for the company who doesn't want any remote connectivity. We can create all this on premises, and so everything we talk about here, think about that mind. It can be on premises or it can be in the cloud. So to make this happen, before we have our BMS layer in the building, and below that you have all your multiple subsystems, your lighting system, your HVAC system, your metering systems, whatever, and they're connected peer-to-peer by a communication protocol. Typically, historically, we're talking about JBus, we're talking about MBus, we're talking about BACnet, Modbus. That's the typical stuff that's there. But so for IoT to work, there had to be a different way of thinking to make this happen, because the peer-to-peer solution that we had previously and still have and are still implementing is labor intensive, because it's only peer-to-peer. It's one system to one system. So if you want to go multiple systems, you're talking about multiplying that and duplicate over and over again. And all of that creates a massive lag in the system and the system performance and how you view the screens and get the information. So to make that, with the IoT solution, the term M2M, or many-to-many, that's really what you're talking about. So to make that happen, we had to think about using it a different way. So the word broker is is an agent that holds the information and to distribute it to other pieces of the puzzle. So we have IoT things, we have multi-sensors, we hear that all the time just going in, these sensors with temperature, humidity, air quality, IAQ going in, and that's fantastic. But there's lots of devices being developed all the time, it's constantly changing. So that information we want to use that in multiple places. So we have a typical BMS system. We have a controller A, B, C spread throughout. One is doing the ventilation, where AHU fans. One's doing the boiler house down below. One's the room controller, multiple room controls. So how does that work? What do we do? So what we do is the multi-sensor publishes the information to a broker. Again, the broker is a service in a cloud-based service, or it's on a server on-prem. Right? So we send that information out. In this illustration, it's temperature, humidity, CO2. What happens then? The controllers, each individual controller can subscribe to just the piece of information it wants, not the whole suite of information. So just a single device or any part we just tell it we want to do. If it has the correct authentication and it's allowed and has the rights to take this information, the broker can then send the information down to the controller. This all happens in real time constantly. So you're not, previously with a Modbus setup, for example, we would have a long sweep of the whole register of the Modbus network, then that would be sent out in its entirety or whatever. So it was a slow, cumbersome result, but it works. Now, also, that information that the broker has the opportunity to send it to an analytics package in the cloud. We see now lots of companies coming out, they want to analyze all your data, give you reports, tell you what to do with it, and all fancy. So how do we do that? We can send that via the cloud to them, to multiples, all looking at the same piece of information at the same time, including the building managers, the FM companies, the control system specialists. And then we can also send that information to business applications. So, in a real-time environment. So practical examples of IoT. This is a never-ending thing. This is constantly evolving on a monthly basis. We see new products and they're coming out. So what we have, the typical ones, you have your HVAC to regulate and control your heating systems, smart maintenance, predictive, telling you hours run, all that information is sent out, that's fine. Smart energy control, digital signage when someone comes into the building, mobile access, controlled access, visitor management, workstation booking, and room booking. This stuff for a second. Think about that. We have a building that it's a multi-shared building, and you invite someone to come to your office. But the smart buildings are now we're going through. They send that invitation to the guest. The guest comes. So he gets an application on his phone telling him where to go. He's given car parking space if he has the privilege. When he arrives at reception, his app or his QR code, as we all seen here this morning, gives him the access. At that point, the smart app that he has on his phone that has been given to him will give him his route mapping to the room he has. If it's a member of staff, and we're going into a situation where we have hot desking is a very hot topic. Now the staff member has requested that he wants to come to the office. He presses he chooses the thing. He's given and assigned a desk. He's assigned a workstation, and this is all practical stuff which is happening now in a smart building. Bring your own device. Again, tracking PCs, tracking stuff inside it. The moving wall principle allows the end user or building manager to modify and change a floor plan layout without the need of electrical and mechanical contractor or a control specialist to come and do that. They actually choose this is the zones we're doing, and combine them together by a click of a mouse or a swipe on the screen, which is interesting. Smart cleaning management, all that information coming back in and sent to the cleaning contractor as a dashboard. Okay, this is where we need to clean. These ones are occupied. These ones weren't going to occupied. All these things again are saving energy. Smart lighting, smart procurement. We can looking at sensors on coffee machines, for example. Even it doesn't need to be replenished or good things to be. I'm blind. Cashless payment. Okay, chip and pin as well. Loading cards for allow staff members to buy stuff. Smart shading, facade management, modulating the facade management system depending on the solar influence or the temperature or position of the sun. Tracking position, finding where colleagues are, how many people are using a certain space from your lanyard, which through iBeacon and products like that, we can actually track exactly how many people are coming in and out of buildings, where they're using more commonly, and which adds to like shade mapping. We can actually give a full map of temperature profiles of floor plans, again in real time. Indoor navigation, giving an application to your visitor, your guest, showing them where the room is, where he's to go, and also making sure you did actually get there. Colleague finder, it's all using the same principle of information, and then find a workplace for hot desking if you're going to allow a staff member to assign them a desk to work on, and obviously smart parking given the park space. So, now. Okay, so basic principles, how this works. Right, there's a few things going on. We have a situation where we have a mixed-use office space, and it's set up for a client. So the user comes in, and he wants to. By using the cloud technologies, we can give the work experience, the wellness experience of the room. Make it much easier for them to control. The illustration I have here is a simple thing. It's that we're going to use this Alexa. So we have a meeting room where we've allowed voice activation, or we have a third-party application screen to allow them to control the whole room. So how that works, the simple voice command, Alexa, turn on the lights, or Alexa, close the blinds, Alexa, and it can be any voice-activated product. That information goes up onto the Amazon cloud. From there, it goes over onto your building automation cloud service. Again, this could be all on-premises, or it could be going across continents at this stage. And it comes down to your cloud connector, and then the cloud connector then to your building management system network and controllers, right? So that seems like a very complex or very long-winded thing, because in reality, the Amazon cloud could be in San Francisco. The Southern or BMS cloud could be in Clonee. But in reality, that happens in milliseconds. Right? So it is that very clear. And then when we get to the room automation level, we can look. We've M-busted and mod-busted conventionals of BACnet, introduction of MQTT, which I'll come up to later on, and what that is. But any of your DALI lighting systems, your KNX or your SMI for your facade management, we have all that at a room controller level now, where before that was a high-level integration. Now we can do that in the room for individual rooms, which aids the retrofit or the change for small projects or smaller installations, where this was only ever considered really for the larger projects. Now, with the flexibility of the products available to us, we can deliver this at a much smaller level. This is an example of a job just done in the past couple of years, where the building was was built between 40 and 50 years ago. Through the lifespan of that 40, 50 years has had a number of retrofits, has had multi-tenants on different floors throughout it. So it started off as a conventional LPHW and chill water distributed system to fan coils, but one tenant came in a few years ago and put in a Mitsubishi VRF system over 2 floors, which was very popular and great system. Another floors were retrofitted, and they put a new ceiling grid and put up a whole new lighting system, and a DALI lighting system was fitted. But the floors are not the same. They're different tenants, but the same management company. So we were engaged to come in, and what we did is we put a cloud connector in, and we did an interface with the DALI system, which was actually already in place through the BMS system. And then we did an interface with the Mitsubishi system and took that up. Now, the DALI system had proximity sensors, had knew exactly how many people, when there was someone in a room. The Mitsubishi, believe it or not, had that already inbuilt on the wall controller, which is not utilized, very, very little. So we were able to take that information, show the occupancy through the floor, what floors were, each floor, what was used, take that information, send it to a cleaning dashboard for the FM provider, and take that information back to ourselves as well. So on a daily basis, they knew exactly what rooms were used and how often they were used and what sort of energy they had. And that was done with the aid of a single device. There was a small bit of network wiring, very small, minimal, no disruption. So no massive capital, no massive capital spend for our client, and they got a great result. So with that in mind, also that information we're able to take back into the BMS system and actually look at, we're working on other projects now at the moment where we are sending information and taking over the Mitsubishi system and changing how it's controlling to add functionality. Nothing wrong with the design or the setup of the Mitsubishi as it was, but we're just enhancing the building by using that data we've analysed and be able to look at. Okay. Now, the fear with this, people think because you're talking about cloud connectivity, you're talking about going outside their buildings. There's this fear that how can we protect ourselves? The layers are there. There's an IC guideline on security for connectivity of buildings, and it is in place. But from a building point of view, once we leave the building, let's say it's typically in a building we have a back net or we have a proprietary network for the actual type of BMS system it is. Once we go up above that, what we do is we're now communicating over an MQTT protocol, and on that has a transport layer security. So what happens? If foreign information is sent up to the broker in the cloud, it has to be authenticated. We have to know, and other than that, it will not be released, and there will be no exchange of information. We have security levels set up that if that is to be compromised in any way, that it will go into isolation mode and it will withdraw completely. So the systems are there, not only in our BMS systems, and also in the IT infrastructure and the firewalls that are in place already with the big end users. But it is in place and it works very well. So with that, and after that, with that mindset, we can join all these buildings together, or we have a client with, let's say, multiple buildings in a portfolio. We can take all that information together and bring it up into a cloud-based service, all through the same protocol through MQTT. Now, we're looking now, and this is the way the buildings, the big end users have pushed us in this direction, that they want to take the servers off premises. They want to take the software off premises, and they want to apply them as a service. So they want software as a service, they want platform now as a service. So your days of maintaining massive servers in your buildings to manage all these systems, we're moving away to that. That is going to go. There was a huge pushback against that because there's a security. Do we have it? How have we got control over it? So if someone said to you 20 years ago that you're not going to be looking at your record collection, that you're going to be paying an online service to store all the music that you listen to, you tell them they're mad. But most people here in this room will have a Spotify account and realize that's exactly what they have done. Right? So this is the way we're going forward. So the big designer, big manufacturers of the software, of the BMS companies and the control packages have platform as a service now in the cloud. So you can actually take all, so this means your upgrades of your softwares, your upgrades are constantly done off premises without any interference. The need to maintain or manage expensive servers is gone. That's been taken off site as well for you. But it also opens the sphere that the information that you have can be shared with so many people now, simultaneously, in real time. It wants to have the correct permissions, and the sharing of the data to make the building far more efficient. So, and maintenance platforms. Now what we're doing now is when we're building a BMS system, we're also looking at the fault detection and analysis system for the building. So we're going in before we start to build the building, getting the fault detection set up. So as we commission the points, the faults that will disappear by managing rules for the air conditioning system or the pump failures. So we know exactly when a building is working at its optimum and can report back on that. So we take all this data we have and we can share with whoever needs to have it and make the system work as efficiently as you possibly can. The algorithms now are developed to go on top of the BMS system. To further enhance them, and that can happen. It doesn't happen in our cloud. We have BMS controllers with client and broker services inside the actual controller. So we can do this even in building level or room level or on your own building stock or platform without going out to other third-party services. So that's okay. So next one, we've introduced blockchain. We haven't used blockchain because we're all supposed to be mining this money and making a fortune. But the reality is, it has opened the world a really secure way to manage systems that are connected remotely or have remote connectivity. So how that's done, the same as the Bitcoin is actually created. It's the exact same principle. By the introduction of an integrity manager, we set up the Genesis block. The Genesis block in the blockchain is the starting point. That gets a hash code, which is a digital fingerprint, which tells you that this is what should be in the first controller. That controller then joins the chain. It's verified that everything is exactly as it's supposed to be, and if it is, it moves on to the next controller. This can be in multiples. It depends on the size of your site, and eventually it goes all the way around, and it gets back to a match at the very end of the blockchain. Then we have an integrity, a blockchain that's the integrity is perfect on. We know that everything's perfect, and that's how the system functions. Now, also by doing that, we get a digital twin of every controller strategy, and we keep that on cloud, or we keep it on a drive, or whatever we want to do. That's fine. So we have a normal BMS system that's working away, functioning, doing all its services, everything's supposed to, and it's all fantastic. If we have a hack internally, or we have a hack externally, or something changes, which is nigh on impossible at the moment, but if it happens, what happens? The blockchain sees this change, and there's a number of things it can do. It can alarm, tell the building manager or the company that's happened. It can quarantine and remove itself from the chain, or it can completely isolate and shut down the chain. We have these options of how to do it. But we also have now self-healing. So if we find that this has happened, we can isolate, take the controller offline, download its original program, verify it, and reintroduce it back into the chain. Now, that might, historically, that would have meant a BMS engineer going to site, getting the program, downloading it, or even a faulty controller download, and there's a labor element involved in that. We're now creating this automatically, right? So we have an intelligent building, which is communicating with third-party devices, internationally or on premises, and it's also looking after itself and self-healing. So this is the way the systems are going, and these are here. This isn't concept again. This is real. It's ready. We're doing it right now in Dublin, and it's a fantastic time to be in the industry. So in summary, smart buildings each one of them is unique. Once you have the foundation, everything is possible. The limitations here as well, I suppose, is our imagination. We have to be constantly looking and figure out what's next and what can we do. I think that the limitation, it's endless. Now, okay, platform as a service. Yes, of course there would be a cost, but there's also a cost in having it on premises, a much bigger cost, we believe. There's easy costs in engineering, there's reduced maintenance costs, and big network gateways, that's all a thing of the past. The rollout of IoT devices and wireless IoT devices, yes, the more equipment we are getting in, new equipment is getting better, the quality of it, the information coming from it is better, and it's becoming cheaper because it's now being mass produced. In the earlier days, these things were maybe seemed to be cost prohibitive. Because their cost, that's the thing of the past. They are really, really reasonable now to install. If you don't have any infrastructure to take these, most of these now are wireless or lower RAN. We can actually take that way. So the infrastructure costs are not as heavy as it used to be. Each one of these devices, obviously, by monitoring a building, as much information as we can, we can make and implement changes to save energy in each of the floor plans. So we take an example of, we have this room here, it can hold up to 10 to 100 people. So it's on the BMS system. Typically in a normal BMS system, this system would be just set to 21 degrees and we hope for the best. 10 people walk in, it's not an issue. 15 people walk in, it's not an issue. 100 people walk in, immediately it's an issue. We have this massive heat gain and we don't. So with IoT, Now, if you book this room through your Outlook or through your booking management system, that the BMS system then knows what's to be expected at that time. Then we can actually precondition this room to cater for the amount of people that's coming in. We're seeing this as massive energy savings. Also, we can take weather data from a meteor service and take it in and preload the building. We're seeing a big change throughout Europe now, where we're going for thermal storage in the building. Having predictive or having weather data in real time is actually aiding that and making it far more efficient. And we're seeing in excess of 30% savings on energy, but from that thermal storage. So without the use of IoT or without the use of this external weather data, that becomes very difficult. There's manual intervention, and we need to now keep driving forward to take that manual intervention away. We want to just have analytics and reporting. Tell me when you think something's going to happen. Let the system tell us what's happening, where we need to go next. And that's it. Okay, whistle stop.
Thanks very much, everyone. Apologies both to the speakers and to the people who've come to attend about the time extension from 1 to 1:30. It was all extremely interesting, and this information is going to be available afterwards. So I suppose if you want to tell anyone who wasn't here for the end part that they'll be able to see all this information, and we look forward to more similar talks in the future. Thank you.